Hi everyone, this is Dr. K. NIRMALADEVI, Assistant Professor, Department of Computer Science, KSR College of Arts and Science, Papiman, Tiruchengodu. My topic is neural network that denotes the Hebbian learning and backpropagation. Introduction to Hebbian learning. Hebbian learning, a fundamental principle in neural networks proposed by Donald Hebb in 1949. It is the basic idea neurons that wire together, strengthens connections between neurons that are simultaneously active, forms the basics for many learning algorithms in artificial neural networks. Variations of Hebbian learning. It is the Oja's rule to normalize weights to prevent unbounded growth. To BCM theory, introduce a sliding threshold for synthetic modification. Generalized Hebbian algorithm to perform the principal component analysis that also used for STBTP that denotes the spike timing dependent plasticity to consider the pricing time of speakers. Multi-layer perceptrons. Artificial neural networks with multi-layers. It consists of input layer, one or more hidden layers, output layers, can approximate any continuous functions to denote the universal approximation theorem that to require the training algorithm to adjust weights and biases. Backpropagation algorithm. Supervised learning algorithm for training MLPs. The key steps are forward pass, calculate error, backward pass, update weight and biases to utilize the chain rule of calculus for efficient computations. The forward class to denote the compute network output to calculate error loss at the output. Backward pass to propagate error backwards, update weights and biases. Convergence and generalization. Convergence. The process of reaching an optimal or real optimal solutions to affected by learning rate, network architecture and initial weights. Generalization. The ability to perform well on unseen data. It denotes overfitting versus underfitting. Techniques to improve generalization, regularization, early stopping and cross-validations. Performance surfaces and optimum points. Performance surface, a multidimensional representation of the error as a function of network weights. Optimum points, to denotes location on the performance surface where the error is minimized. Types of optimum points, global minimum, local minima. Global minimum, the lowest point on the error surface. Local minima, 2 points where the error is lower than neighboring points. Challenge, avoiding local minima to find the global minimum. Taylor series in neural networks. Taylor series a way to approximate functions using polynomial expansions. Application in neural networks analyzes the behavior of the error function near a point, approximating complex activation functions to studying the convergence properties of learning algorithms. Helps in understanding the local geometry of the performance surface. Performance optimization techniques. Gradient descent methods to steppers descent, Newton's method, conjugate gradient and Newton's method of key concepts. Steepest descent to moves in the direction of negative gradient, Newton's method uses second order derivatives for faster convergence. Conjugate gradient to combine the benefits of a steepest descent and Newton's method. Key concept of learning rate and momentum to control the step size in weight updates. To control the momentum to help overcome local minima and speeds of convergence. Advanced optimization concept, directional derivatives, necessary conditions for optimality, quadratic functions that all those on optimization concepts in first order condition, second order condition and also used for optimization algorithm near the optimum algorithm. That also used for the directional derivatives to change and error to functions in the specific directions. Necessary conditions for optimality, first order condition gradient equals will be 0. Second order condition, the positive differentiation matrix will be 0 or 1. Quadratic functions, special cases where the error surface is a quadratic bound. It is useful for understanding the behavior of optimization algorithms to near the optimum. Thank you so much for watching. Thank you.